Good afternoon. This is lecture number 13. Again, date 1/3/2021. We look at the Truss problem. So we have just learned how do you do an analysis of a truss for a given joint loads. The loads can be only at the joints for the truss, because the members forming the truss is not capable of carrying lateral load, as there is no also the mass of the slender member, the weight of the slender members are neglected. That's also another important assumption that you have to look at the amount of load they carry, they transfer, right? So we have just finished a problem, looked at a problem for that. So let us take another problem to confirm our understanding and see that we will learn another procedure of solving the problem, which is very important method, right? So let me just explain you this truss. So look at this truss. As I have told, a truss has to be formed by arranging the members, slender members, in a triangular fashion. So I have here this arrangement. I'm going to sequentially add to this so that I can develop my truss. So what am I going to do? I'm going to add members like this. See, now again I have formed another triangle. So this is going to be a truss. Again I'm going to add another member like this. So that's going to form a triangle. So again this is going to confirm the structure nature, right? You can just check now if this is only the truss that I consider, that equation to check whether it's a perfect truss can be examined at this moment. So m is equal to 2j minus 3. So look at now how many members, joints are there? 1, 2, 3, 4, 5 joints. So 2 into 5 minus 3 is 10 minus 3, 7 members. So check how many members are there? 1, 2, 3, 4, 5, 6, 7 members are there. So it's a perfect truss. So in this fashion, if I keep arranging, I can develop my truss. So look at, this is not the truss that I'm going to consider now. I'm going to develop further. So I'm going to have again this as a base, truss develop parallel to this member initially, whatever that I have. I just develop it like this. Again, I have a member here. Member here. Member here. Member here. So now what has happened? How many members I have added? 1, 2, 3. Is this a member here? There is no member here. So let me just erase this portion. This is not a member. Right? So this way. So now how many additional members? 1, 2, 3, 4, 5, 6. So if I add 6 member here, it is 13. So number of joints. So 16 by 2 is j. So 8 joints. So 8 joints are the total. 1, 2, 3, 4, 5, 6, 7, 8 joints. See, every time this is that way. If you are developing your structure, it will be statically determinate structure. So I still have one more over this. Like this, I can have a bigger truss. Like this, I can have a bigger truss. So I just have added 2 more members. So it's 15 members, and with the number of additional joints, 1. So if I put here joint now 9. It is 18 minus 3, 15 members. That is also satisfied. So now I have 15 members. 2 into joints are 9 minus 3. So it is 18 minus 3, 15, perfect truss. So you understand what is this equation requirement to check statically determinate truss or not. So now this truss is now loaded by horizontal loads. So what are those loads? Just let me just put them here. I have a 15 kilonewton load at this joint, and 15 kilonewton load at this joint, and 15 kilonewton load at this joint. Right? So these are the three 15 kilonewton loads. Three 15 kilonewton loads, and their dimensions, the truss dimensions, are to be read in this fashion. So the total span from this joint hinge to this roller is 4 meters, out of which till this it is 3 meter and this is 1 meter, and this vertical height is 2 meters, 2 meters, and further 2 meters. So the total height of the truss is 6 meter and width is 4 meters. All are in meters, so I mentioned at one place the unit. So now I'm not going to ask you to find out, analyze the complete truss. If I do ask you, you know what is the first step. You'll draw entire truss free body diagram. You'll find the support reactions at these points. So for that, let us name them. Name it for convenience. So let the hinge point is my joint A, and this is joint B, and this is joint C. The topmost is joint D. This is joint E. This one is joint F, and this one is joint G. And I have these two. One is joint H. This is joint H. This is joint I. So I have this many number of joints. 9 joints I have now, and I have 15 members, and that satisfy this equation. And this is my perfect truss, statically determinate truss. So my question is now to you is not to analyze this. Of course, you do that as a homework, as you have learned this method of analysis, the procedure called method of joint. Method of joints. You draw the free body diagram of individual joints and you find out. And now we are going to learn another method called method of section. So what is this method of section and method of joint? Basic difference. Method of joints, as you draw free body diagram of the joint, you have planar concurrent system of forces in free body diagram. So you require only sigma fx equals 0 and sigma fy equals 0. Only these are the two equations sufficient for method of joints to solve. Whereas in case of a method of section, I'm not going to consider the joint equilibrium. Rather, I am going to take part of the truss. I will cut the truss into 2 parts and then take 1 part of the truss, and I will be looking at it. So when I make an entire truss of the dimension 4 meter and 6 meter height into say 2 parts, I would have the dimension of individual parts, unlike a joint. In a joint, you don't require a dimension. So in such cases, you will have a system of force in free body diagram would be general system of force. In FBD. So hence what would happen? You can solve for 3 unknowns in the problem. Sigma fx equal to 0, sigma fy equal to 0, and taking moment at convenient point equal to 0. So you would solve for 3 unknowns. That's possible. Whereas here you can only solve for 2 unknowns at a time. 2 unknowns at a time. So that's a basic difference. So you have to exploit the situation requirement using any of this method of your choice, if it is not mentioned in the problem while solving. So now my question is to find out the internal forces in a particular members. So what are those members in particular I am interested in is member AB, which I am representing by this color, and member FG. Only I am interested in finding out these 2 members, what are the internal force. If I ask you that question, and at the moment you have learned method of joint, you would apply this method and solve this problem and you can answer. The advantage of now I'm going to explain you solving this problem in method of section is tremendous, as it can save a lot of time, and in one go you can even skip the first step of determining the support reaction and solve. So that is an advantage of method of section. So that is why you should learn both the method, and you should invite the method according to the need of solving the problem. Okay, supposing I am solving this problem applying the method what I have learned or what I have taught you in the last period, the method of joints. How do you start solving this problem? So you would go with the first step and draw entire truss free body diagram, and here I will have GY, and here I will have AY and AX. So AX will be 45 kilonewton. And I can find out AY and GY by taking moment about point A. What is GY? I can find out, and sigma Fi, if I apply, I can find AY. So I will first step, I will find the support reaction at this point and this point. Then I have to start with the method of joint. I have to choose a joint. Suppose I start with the joint A. Why I am interested to start with the joint A? Because that has got an unknown here. But you look at here, there are three members at joint A. But I have only two equation limited, so that will not help me to solve for my interested member, because there are three unknowns. Okay, on the other hand, I come to joint G, the same situation. Here also I have three members, so I will not be able to open a joint with the three unknowns. That's a limitation of method of joint. So in method of joint, you can open your analysis from a joint where you have only two unknowns. That's exactly that you can see in the previous problems here, last period problem you can see. So we have found out here AY, DX, DY. I have not started drawing, solving the problem by drawing the free body diagram of A, neither D, because A, because I have here three unknowns. I could have started with the D because two unknowns. I have started with the joint B. So that's so I have to open my analysis with the joint of two unknowns only. That's a limitation in method of joint. But here, if that is that limitation, I am very much aware. I have to use this method of joint only to find out these two. Let me choose some other joint other than A and G. So if I come to joint B, see there are four unknowns. Joint H, four unknowns. F, four. So if I keep looking at like that, it is taking me to the uppermost joint D, where I have only two unknowns. Then I can very well start from here, right? I will find out these two. Then I know these two. Like that, if I start from joint B, then joint C, then joint E, then I will come to joint I, then I will come to the joint here. So by the time I will have to consume lot of time, and in meanwhile you may also make sometime mistake, and that will lead to a wrong answer. In such cases, you would appreciate the application of method of joint is very, very viable and recommended. So what I should do, I should cut this truss into two parts. So the cutting of the truss can be by straight plane. I can use a straight plane. I can make it by a straight line, or I can also use a curved plane. That is my choice. But I make it into two parts. That's very important. So when I make truss into two trusses, broken trusses, and both the trusses should be under equilibrium. Both the broken parts should be under equilibrium to ensure the entire truss equilibrium. That's important, right? So if I have to have a straight plane here, I can cut this member AB passing through that straight line. So that cuts so many members. Again, cutting more than three members by a straight plane is not recommended in method of section. You can cut it more than three members by curved plane. In this case, you would see that I am going to represent you. Instead of asking you what is the appropriate plane, I myself will represent a plane and you see. So I'm just going to take a section plane like this. So I'm going to cut this truss by this curved plane. So it cuts how many members? Member AB, member BH, member HF, and member FG. Four members are cut. and it makes a truss upper part and lower part. In upper part, I don't require this support reaction. In lower part free body diagram, of course, I require this support reaction. So I would choose wisely upper part free body diagram and solve the problem in one step, finding these two unknowns. So that's what I'm going to do. So what is that I'm going to do now? I'm going to take a free body diagram of the upper part of this truss drawn. So upper part of the truss drawn free body diagram would be this. So I have this member, then it's a dotted line, this joint, dotted line, then the member above which I have this, I have this. Just redraw this. So what is my section plane? Is this section plane? This was my section plane. Like this I have considered. And now see my internal forces I represent here. This one, this one, this one, this one. These are the four unknown internal forces. This is F, B, A. This is F, G. These are the two things asked, and this is F, B, H, and this one is F, H. FFH. These are the four unknowns. What are the external loads? At this joint I have 15 kilonewton. At this joint I have 15 kilonewton. I have also at this joint a 15 kilonewton load. So look at now, I have just drawn the upper part, right? So here the naming, let me just do, this is B, this is C, this is D, this is E, this is F, and this one is H, which is in the bottom part. I'm not bothered about it, and this is I here. So now, other than, see now this joint C, D, I, E, F and all not disturbed. They are there in the truss. What are disturbed now is, instead of taking a joint, I cut the truss so that the members are cut. Now I look at the members here. So I represent the members like this. You know, internal force, how is this represented when the arrows are coming to the center. So these are tensile nature. So this joint is pulled. So these are tensile nature, I assume. I just going to solve. So now here, this section is a hint I had given, or also you have to apply your mind and find out is this an appropriate section. Why this is an appropriate section is because if I look at point B, I have at this point B 3 out of 4 are concurrent. They have a common intersection. This one, and the line of action of this goes through this. So this is only unknown. So by taking moment at point B, I will be able to find out this unknown. And again, similarly, this joint F, if we look at, I have out of 4, 3 are concurrent at that point. So fourth one I can easily find out again by applying moment equilibrium. That's all. This is the idea. So this is an advantage of method of section. So let me find out now FFG by taking moment about point B 0. Applying counterclockwise moment positive. So now these distances are known. This is 2 meter and this is 2 meter. These distances are known. Right. So now what are the moment equations? This 15 Newton, 15 kilonewton load horizontal joint D would create at point B a clockwise moment. So minus 15 into 4, and this 15 would create again a clockwise 15 into 2, and this 15 will not participate in the moment equation, and only this is now left. So f of g, and that would create again clockwise. So minus f g into what is this total span? 4 meters. So 4, that's equal to 0. So what is my ffg? So this minus going on that side is positive, and this side I have negative. So it is 60 plus 30 by 4. It is 90 by 4. It is minus here. Minus. So I get minus 22.5. So it is 22.5 kilonewton compression. Is what is FFG. FFG. So what is my answer here? This number FFG is under compression. So how do I represent compression? It should compress the joint, internal force. So this is the representation of compression. Compression 22.5 kilometer. See, it's one step I have solved. And similarly, I can find what is now my FBA by taking moment at point F. So I can just have another equation to solve my problem. So that is sigma m F equal to 0. With the convention, counterclockwise moment positive. So when you take moment about this point, I would have this 15 kilonewton force, this 15 kilonewton force, and this FBA comes into the equation. And this would create about this point F now. Look at this is downward direction. The moment arm would be rotating virtually in a counterclockwise sense. So I would have now FBA into 4, which is positive. And then about this, these two would create clockwise moment. So minus 15 into 4 minus 15 into 2, that's equal to 0. So what is that I will have now? FBA is going to be 90 by 4, which is 22.5 positive value, so it is under tension. So I have the other one on the other hand by tensile nature member. So this member is under tension. So this is under tension. So how do I represent that? I'll represent it in this way. So this is under tension by 22.5 kilometer. So that is all. So this is an advantage of solving this problem by method of section instead of going with the method of joint. However, I'm going to give you this problem as homework to find out an internal force in all these 15 members by method of joint, and you would see that the method of joint is also a best method to find out on all members. When it is asked, you can go for that, and if it is very specific members asked like that, then method of section is good that you would appreciate. So I have explained you in this problem the advantage of method of section, the procedure of method of section, and I ask you this same problem to be completed as a homework by method of joints. So you solve by method of joint, opening the joint D and find these two, and the orientation you can get it from the dimension. So the orientation means what? This angle here, theta C. So what is theta C here? So theta C will be tan inverse of opposite side is 2 by 3, and this is theta E. So theta E would be tan inverse of opposite is 2 by 1. So you have this orientation. So you know the direction is unknown. So find these two, then come to this and find this. Like that you find and analyze the entire truss. You will be left with one joint and cross check your procedure is correct. So you can self-evaluate you are doing it correctly. And you see you would have these values which are asked in specific in this problem, right? Only internal members. What are the members? The AB and GF are asked. For these two members only are asked, that you can cross check that is solved.